guys, tonight we're going to go over the distributive properties. All right, this should be a pretty easy lesson from what we've seen. It says use the distributive properties to evaluate each expression. All right, remember we want to take whatever's on the outside of the parentheses and apply it to everything on the inside the parentheses. That means we're going to take 2 and we're going to multiply it to 16 and we're going to multiply it to -6. Normally we'd follow PEMDAS and work what's in the parentheses first, but since we are trying to prove that we know distributive properties, we're going to go by the rules of the lesson and apply what's outside to each of the numbers inside. If we do the first one, we have 2 times 16, and 2 times 16 is going to be 32. Now, we also have to go ahead and distribute 2 to -6, and 2 times -6 is -12. Now we have 32 minus 12, and that's pretty easy. We got 20 left. That takes care of number 1. I'm going to go ahead and work number 3 right now and leave the even ones for all you students. We have -3 on the outside on number 3, and we got to apply that to -7 and to 2. -3 times -7, well, that's going to be a positive 21. And -3 times 2, well, that's a -6. So now we have 21 minus 6. We take 21 minus 6, and I'm thinking we're going to have 15. Number 5 is our next one, and it says 5 times 7 plus 3. So we have to take 5 and apply it to 7 and to 3. If we do that, we have 5 times 7, which is 35. And we're going to add it to 5 times 3, which is 15. Well, 35 plus 15, that's going to equal 50. All right, let's go ahead and jot down to number 7 here. It says use the distributive property to rewrite each expression. This time we're going to rewrite each expression. Now, since we see that we have variables inside of our parentheses now, we're not going to be able to go ahead and solve for a numerical answer. We just need to distribute what is on the outside to what's on the inside. If we do that, we have 8 times 2, and 8 times 2 is 16. And then we're going to take 8 times positive g, which means we're going to have plus 8g. And we can't do anything else to this because we don't know what our variable is, which means we can't combine 8g. And remember, we have to follow PEMDAS. Multiplication has to come before we do addition. So we cannot combine 16 with 8g. We stop right there. Number 9 says we're going to take -7 and we're going to multiply it to 5. Well, -7 times 5 is -35. And then we have -7 times -n. Well, that's going to be a positive because a negative times a negative is a positive. And we have to leave it as 7n because we don't know what n is. And that leaves us with -35 plus 7n. Let's go to number 16 now, where we have 6x on the outside and y minus z on the inside. That means we're going to take 6x and we're going to distribute it to y and to -z. 6x times y is 6xy. And 6 times -z is going to give us a -6xz. We cannot combine these two because, again, the subtraction sign in the middle prevents us from combining these two, I guess what you call coefficients and variables that are together. So since these expressions here can't be combined, we're going to leave it as 6xy minus 6xz. And let's go to number 13 now. If we read this out, it says the table shows the different prices at a dinner. The items at each part of the dinner are the sandwiches, the drinks, and the desserts. And the cost is $5 per sandwich, $2 for the drink, and $3 for the dessert. It says write two equivalent expressions for the total cost if 2 customers ordered each of the items. Okay, let's go ahead and work that out. If we do that, we've got, okay, if 2 customers order it, so we're going to have 2 on the outside that has to be distributed to everything on the inside. And that's going to be $5 plus $2 plus $3. And if we want an equivalent, it says, 2 equivalent expressions. This would also equal 2 times 5 plus 2 times 2 plus, looks like 2 times 3. And that would be 2 equivalent expressions. Now it says, what is the total cost for both customers? And before we go any further, I'm going to pop in a secret code word for you guys to tell me when you come in that will let me know you watch the video. My code word for today, and I'm going to write it up here in the corner. My code word is, let's see, I'm going to go with root beer lollipops. Okay, so if you write root beer lollipops at the top of your page, I will know that you watch the videos. All right, and we'll just move that right up there. Now you know what the code word is, and I'm going to erase everything. For those of you that try to fast forward through the video, you will not be seeing any of this. For those of you who did watch, congratulations, you did what you're supposed to, and I'm very proud of you. Let's go ahead and erase the rest of these that are on the page, and now we're going to the question. What is the total cost for both customers? Well, if we have 2 times 5, that's 10, and 2 times 2 is 4. Well, 10 plus 4 is 14, and then 2 times 3 is 6, so 14 plus 6, that's going to give me 20. So the total cost for 2 customers is going to be $20. Let's go to number 14 now. Number 14 says, sundaes. Carmen bought 5 ice cream sundaes for his friends. If each sundae cost $4.95, how much did he spend? Well, right off the bat, if I was going to just solve this, we all know I would regularly take my calculator and I'd simply put in $4, 4.95, and I would multiply it to 5, and I'd get my answer. That would be $24.75. So let's write that in. $24.75. Okay, now it's asking us to go ahead and justify my answer by using a distributed property. Well, if I was going to use distributed property, I wouldn't try to mess with $4.95. I would probably say that I could break that up and say I'll take $5 and I'll multiply it, 5 and multiply it to $5. Okay. And let's see, I'd have to subtract $4.95. I'd have to subtract 5 cents, right? So let's see, we're going to put this in parentheses, $5 minus 0.25. Okay, and if I was to work this out, I would say, well, $5 times 5, that's $25. And I would say that $5 times 25 cents is $1.25. I believe that's $1. Oh, hold on. This isn't 25 cents. I stand corrected. It's actually a nickel, 5 cents. So we're going to change that out. 0.05. My apologies. And 5 times 5 cents would be minus 0.25. So we're going to subtract a quarter. All right. And we both know, we all know that $25 minus 25 cents equals $24.75. And that's exactly what our calculator said. So we use distributed properties to go ahead and give us the answer that we were looking for. That was the last question. So you all have a good night, and hope you had a good weekend.